Hello, Algebra students. Today we're going to be going over the Unit 3 bookwork. So hopefully you have your book with you. Looks like this. And basically, I want you to write down the question, and I want you to write down all the work that comes along with it in each box. If you kind of just follow along with what I'm doing and answer the questions that I tell you to answer on your own, then you should be doing fine. For the word problems, you don't have to write the question, but I do want to see the answer written out in a complete sentence. That's about it. And remember, complete sentences start with a capital and end with a period. So make sure it's a complete sentence that explains your answer. Well, with that, let's go ahead and get started. So let me share my screen here. And go ahead and turn on your textbook to page 85, and we'll go ahead and get started. Now, a lot of these, if you just finished all the guided practice before this, then you should be able to do most of these, I would think, on your own. But we'll go over them again regardless. We'll go over a lot of these concepts regardless. So here we have 6 equals x plus 2, and your goal for these problems is to solve for x. So you're trying to get x by itself. Now, the first thing to cancel out this plus 2, you go ahead and subtract 2 both sides of the equation, both sides of the equal sign. Here we all have x on the right, and then 6 minus 2 is 4. Okay, so 4 equals x. Now, you could always check your answer. Here it asks you to check your answer, but I want you to just, you could usually plug it in your head, right? 6 equals, and then we're saying 4 is x, right? So 6 equals 4 plus 2, right? Isn't that correct? Yeah, it is. 6 does equal 4 plus 2. So you know you did it correctly when it actually is equal, right? Okay, I want you to go ahead and try number 11 on your own, 12 on your own, 13. This one's going to have a negative answer, so I'm going to go ahead and work this one with you. So here we have 4 equals q plus 13. Now, I want to also mention, if you feel like you could do a lot of these on your own, just do them on your own, right? Even if I'm going over it, you could just pause the video and do them on your own if you feel like you've got it. So, and then you could just see the video to see what I get and to check your work. So anyway, if I'm trying to get q by itself, you could subtract 13 both sides. Here, this would give you negative 9 equals q. Okay, and you're done. Okay, once you have your variable, in this case q, by itself equals, and it tells you what it equals, then you're done. Okay. Try number 14 on your own. 15. Oh, we don't have to do 15. 26. So now we're going to go to 26. Here we'll have negative 8n equals negative 64. Why did I write 16? Negative 64. Okay. So what we're going to do is divide both sides by negative 8. So whenever it says like something right up against the variable, remember that means that those two things are multiplied. So negative 8n means negative 8 times n. In order to cancel that, you divide by that number. So we're going to divide both sides by negative 8. Here, that'll give us n by itself now, because these cancel, equals negative divided by negative, that's positive. So we're going to get positive 8 here. And again, you could always check your answer by plugging in back into the original equation. Negative 8 times positive 8 equals negative 64. That's true. Okay. 27. Go ahead and try this one on your own. 28. Try this one on your own. And again, you could use a calculator for these. There's no shame in using a calculator. I use one all the time. Try this one on your own. This one has decimals, but don't worry, it's not any more challenging. Just get the a by itself there. 30, try this one on your own. And again, if you did the, if you watched this video, if you watched the previous video and did the guided practice with me, then these shouldn't be too much of a problem. Okay. 34, let's go ahead and work on this one. So this is m over 7 equals 12. So hopefully you remember from when we did the guided practice that when you have a fraction, what you want to do is multiply everything by that denominator of that fraction. So we're going to multiply everything, in this case, by 7. And what that does is when you multiply this times 7, it cancels with the denominator. So that's just going to leave you with m. Then you multiply this by 7. 12 times 7 is 84, and you're done. Once you have m by itself, you know you're done. And again, you could always double check. 84 divided by 7 does indeed give you 12. Okay. With that in mind, try number 35. Try number 36 and 37. So I'm asking you to do all these on your own. I know you can do them. Okay. This one's going to have a negative times a negative. So just remember, negative times negative gives you a positive. Okay. Same with number 40. 42. So this one's a little bit different, but we'll go over it. So this is 2/3 q equals 18. So again, whatever the denominator is, that's what we're going to multiply by. So in this case, we're going to multiply everything by 3. So when you multiply this term by 3, so again, we're multiplying 2/3 q times 3. And we're multiplying this by 3 as well. Okay, that 3 gets distributed to everything in the equation in this case. So when you multiply this fraction, this 3 cancels with the denominator here. So that's going to leave you with 2q. So you still have that numerator and you still have that q also. Just the 3 cancels with the denominator here. 3 times 18, well, that's 54, I believe. Yep. And then to get q by itself, we're going to divide both sides by 2. That'll give us q by itself. So that'll give us that q equals 27. And you're done. And again, you could always check your work. 2/3 times 27 will give you 18. Okay. 43. Let's do another one. This one's very similar, just with different numbers. So we'll go ahead and work on it together. So we got 3/4 x equals 9. So what am I going to multiply everything by? In this case, we're going to multiply everything by the denominator, in this case, 4. So multiply this by 4 and multiply this by 4. So when you multiply this fraction times 4, this 4 cancels with this 4, leaving us with 3x. On the right side, 4 times 9 is 36. Dividing both sides by 3 to get x by itself gives us that x equals 12. Okay, that's it. 44, I want you to go ahead and try this on your own. If you understood the last two, then this one shouldn't be any harder. 45, try it on your own. 46, this one's a little bit different. Okay, this one's got multiple fractions. Here we have 1/5 x equals 2/7. Okay, so in this one's case, we've got two different fractions. So what should I multiply everything by? Well, when you have multiple fractions and you want to cancel all of them out, what I would do is you simply want to multiply by the lowest common denominator. So in the case of 5ths and 7ths, what would be the lowest common denominator? You could always list out their multiples, right? The multiples of 5, 5, 10, 15, 20. And the multiples of 7, 7, 14, 21, so on, until you find one they have in common. In this one's case, the lowest common denominator will be 35. Okay, so we're going to multiply this by 35, right? So 1/5 x times 35. And we're going to multiply this times 35, the 2/7 times 35. Now, you know you did it correctly if the fractions all cancel, okay? And indeed they do. So when I do this 35 times 1/5, what you do is the 35 and you just divide by 5. So 35 divided by 5, that's 7. And then you multiply by the 1 here. So 35 divided by 5, that's 7. 7 times 1 is 7. So it will be 7x here. On the other side of the equation, 35 times 2/7, again, you do 35 divided by the denominator and then multiply by the numerator. So 35 divided by 7, that's 5. 5 times 2 is 10. Now to get x by itself, we divide both sides by 7. Divide by 7. Here, our answer for x is a fraction. That's okay. If you have a fraction as an answer, that's fine. I would just make sure that if I have a fraction, that it doesn't divide or simplify anymore, right? So this fraction is already in simplest form, so you cannot simplify it anymore. I would just say that's your answer. Okay, so having a fraction answer, that's fine. Okay. Try 47 on your own. Here you'll be multiplying both sides by 9. Try 48 on your own. And 49 on your own. And that's it for this section. So go ahead and finish the rest of these in the section. If you need to pause the video and work on those, please do so before going on to the next section. Okay. Now the next section starts on page 91 in your textbook. Now, I do want to emphasize that you don't have to do all of these all in one sitting, okay? If you're only doing like a couple sections today and then do a couple more sections tomorrow, that's fine. That's mostly what I would suggest. But if you feel like you can concentrate and you can do all of these all in one sitting, you can do that as well. It just might take you a couple hours. Okay, I'm doing them all in one sitting, but of course I'm skipping a bunch of them for you to do on your own. So it'll probably take you much longer. Okay, let's work on these ones here. And again, if you, on page 91, starting with number 12 here. Again, if you did the guided practice and it all made sense, then hopefully a lot of these problems aren't going to be too hard. But I'm going to show you how to do it regardless. So what I want here is I want to get n by itself. So what we're going to do is going to add 4 both sides of the equation. This will give us 3n on the left equals, and then 11 plus 4 is 15. To get n by itself, we would divide by 3 because this means 3 times n. So the opposite would be to divide by 3 to cancel it. Divide this by 3 as well. Remember, whatever you do on one side of the equal sign, you always do to the other side of the equal sign. 15 divided by 3 is 5, and that's the end. Okay. You know you're done when it says the variable equals and then just a number. Okay. And you could always double check to make sure it's right. If you did 3 times n minus 4, you should get 11. And since our n is 5, that would be 3 times 5. That's 15 minus 4. Yeah, that does give you 11. So you could always check it by plugging it back in. Okay, 13. This one says -1 equals 7 plus 8x. So here we're trying to get x by itself. So what we're going to do is go ahead and subtract 7 both sides of the equation. Here we'll have -8 on the left equals, and then on the right, 8x. Dividing both sides by 8 to get x by itself. Here x will now be by itself. X equals -8 divided by +8 is -1. Now, I know you mostly usually see the variable on the left side of the equation, but here having the variable on the right side, that's perfectly fine. It doesn't make a difference. So 14. Here, this one's got a fraction in it, right? It says y over 5 plus 2 equals -8. So I want you to look here. You want to multiply everything by that denominator. In this case, 5. So this 5 gets distributed here, and distributed on the other side of the equal sign as well. Okay, it gets distributed to every single term. When you multiply it by this first one, it cancels the denominator, leaving us with just y, right? Or 1y, same thing. 5 times 2 is 10. So the 5 gets multiplied by this 2 as well, and also distributed to this negative 8. So 5 times negative 8, that's negative 40. To get y by itself, we're going to subtract 10 both sides of the equation. That'll give us that y equals negative 50. $15, I'm going to let you go ahead and try that one on your own. 16, this one has a fraction too, but if you saw how we did number 14, number 16 is very similar, just with different numbers. So go ahead and give it a try. Same with 17. All right, now we're moving on to number 26. These look a little bit different, but they're actually not too bad at all. So these look, say, y minus 4 over 2 equals, and then on the right side we have 10. So again, we multiply by whatever the denominator is. In this case, 2. So this 2 gets distributed to this thing, y minus 4 over 2, and also gets distributed to the 10 on the other side. So when you multiply the 2 times this thing, all it does is it cancels the denominator. So what you're left with is y minus 4. The 2 also multiplies with the 10 over here, so that makes 20. Lastly, to get y by itself, we're going to add 4 both sides of the equation to cancel that. Here we'll have y by itself, y equals 24. And again, you could always plug it back in to make sure that it works, right? Plug it back into the original equation. 24 minus 4 is 20. 20 divided by 2 is 10. So we know it's correct. Let's do another one together. Number 27. 7 equals, and then over here we have x minus 8 divided by 3. So what do I need to multiply everything by? In this case, I hope you see that we would multiply everything by 3. 3 gets multiplied with the 7 and also with this side as well. So 3 times 7 is 21 equals, then when I multiply 3 times this fraction, it just cancels with the denominator, leaving us with x minus 8. To get x alone, we're going to go ahead and add the 8 both sides of the equation. Here, that'll leave us with x on the right and 29 on the left. Okay. 28, go ahead and give that a try on your own, as well as 29. Okay. Now let's move on to the next section. So on page 98 through 99 in the textbook. And we're going to start with number 11 here. So once your turn there, and let's go ahead and write down the first problem. It's 72 plus 4 minus 14d equals 36. Okay, so in this one, we're going to combine like terms on the left side. So hopefully you can see on the left side, we can actually combine this 72 and this 4. They are like terms. They're both just numbers. They're constants. So whenever you see that, you can combine those together. So in this case, 72 plus 4 is 76. Now, it's important to note that they're both on the same side of the equation. So I can't combine these with the 36 as it is right now. I can only combine on that side. I want to see on this side of the equation, is there anything I can combine? Yes. Okay. But I wouldn't combine it with the 36 yet. Okay. We still have a minus 14d equals 36. So now we would subtract 76 both sides of the equation. Okay, that would give us negative 14d equals, and then on this side, this would be negative 40. Make sure I'm doing the right problem. Page 98, number 11. Yep. Okay. Then divide both sides by -14 to get d by itself. Again, the -14 right up against the d, that means they're multiplied. So we would divide to cancel it. Here that gives us d equals a negative over a negative. I could just make that positive. And so we have a fractional answer because this doesn't divide evenly, but we want to see if we can simplify that fraction. Whenever you get a fractional answer, always make sure and check to see if you could simplify. Now in this one's case, we can divide both top and bottom by 2, giving us 20 over 7. Divide top by 2, divide bottom by 2, 20 over 7 is our answer for D. Number 12. Okay, so the number 12 says 13 equals, and then we have 5 plus 3b minus 13. So when I look at this, is there anything on this right side that I can combine together? Well, yes, I can combine this 5 with this -13. So here we'll have this 13 on the left, the 5 and this -13 combine. That gives us -8 when I combine those, right? Here it'd be negative because I have more negatives. But since they're different signs, they actually subtract each other, right? But I keep the sign of whatever there's more of. I still have a 3b over here, so we'll call it 3b minus 8. We're going to add 8 to both sides of the equation to get rid of that. $3b over here is on the right, and on the left, this gives us 21. Divide both sides by 3 to get x, or sorry, not x, to get b by itself. B is 7. Okay. Now, I want you to keep in mind that we get rid of whatever's adding or subtracting first, then we get rid of whatever's multiplying next. Okay. Let's do another one. So here, number 13, we got 6p minus 2 minus 3p equals 16. So is there anything I can combine together over here on the left side? Well, yes, we can combine the 6p and this -3p. When those combine, that gives you 3p. It's essentially 6p minus 3p. That's 3p. Okay, we still have a -2 over here and 16 on the right. We're going to go and get rid of this -2 first. So we're going to add 2 both sides of the equation. Canceling it over here. 3p equals 18. Divide by 3 to cancel it here. And then we'll have to divide this side by 3 as well. P equals 6, and you're done. Remember, whatever you do to one side of the equation, you have to do to the other side. Let's do number 14 together. X plus 2 plus x equals 22. Now, hopefully you can see on the left side, we can combine this x plus another x. You could think of these as 1x. I don't know if that helps thinking about it, but if I've got 1x plus another 1x, that's 2x. Okay, you don't have to put the ones there. X plus x should give you 2x. We still have a plus 2 over here, equals, and then 22 on the right. To help us get x by itself, we're going to subtract 2 both sides of the equation. Remember, whatever you do to one side, you have to do to the other. So here we'll be left with 2x on the left equals 22 minus 2 is 20. To get x by itself, we're going to divide by 2 both sides of the equation. Canceling here, x equals 10. And again, you can always check your answer by plugging it back in. So if I did 10 plus 2 plus 10, yeah, that indeed does equal 22. So I know I did it right. Okay, number 15. I want you to go ahead and try number 15 on your own. Number 20 is a word problem. So remember, you don't have to write down the question, but I do want you to write the answer in a complete sentence. I'm probably not going to write the answer in a complete sentence, but I'll give you a good explanation so that you will be able to write the answer in a complete sentence. Okay. But we also want to see some of the work regardless. Okay, number 20. It says, a family buys airline tickets online. Each ticket costs $167. The family buys travel insurance with each ticket that costs $19 per ticket. The website charges a fee of $16 for the entire purchase. The families charge a total of $1,132. How many tickets did the family buy? Okay, so they were charged $167 times however many tickets they bought. So we're going to have X be the number of tickets they bought. They're charged $160 X, meaning 167 times however many tickets they bought. They also bought travel insurance with $19 per ticket. So plus, they also bought $19 insurance times however many tickets they bought. They were also charged a $16 transaction fee on the website. So that's a $16 charge. This one's not per ticket. It's just a $16 charge for the purchase. And then this should equal a total purchase of $1,132. Okay. So hopefully you can see how to solve this. What I would do first is combining the 167x plus the 19x. So that would give us 186x. Here we still have a plus 16 both sides, or plus 16 over here, and then 1,132. What do you think we do next? Well, what I would do next is subtract 16 both sides of the equation. This will help us get x by itself. So we have 186x equals 1,132 minus 16 gives us 1,116. Divide both sides by 186 to get x by itself. This will give us that x equals, let's go ahead and use a calculator here, 1116 divided by 186, 6 tickets. Okay, so they bought 6 tickets. Okay, so I want you to write the answer. Since it's a word problem, I want you to show this work, but also write the answer in a complete sentence. So that complete sentence might sound something like, the family bought a total of 6 tickets. But remember, complete sentences start with a capital and end with a period. Okay. All right, I'm going to pause the video for lunch, and I'll see you guys in a bit. Okay, now we're on number 21 here. So that one says 64 equals, and then we have 8r plus 2. So 8 times r plus, I said 8 and I started writing 8. No, 8r plus 2. So what we want to do here is we want to first, hopefully you remember, we want to distribute this 8. So the 8 multiplies with everything in this parentheses. So we're going to have 64 equals, and then we'll have 8r plus 16. Now, hopefully you remember, we want to get rid of whatever's adding or subtracting first. So we're going to subtract 16 both sides of this equation. That'll leave you with 8r on the right, and then 64 minus 16, 48. Then to get r by itself, we divide by 8 both sides, and that'll cancel that out. So then what we'll be left with is r on the right, and then 6 on the left. And again, you could always check your answer to make sure. If I replace 6 with, place r with 6, this would be 6 plus 2, which is 8. 8 times 8 is 64. So I know it's correct. With that in mind, see if you could do number See if you can do number 22 on your own. Try number 23, 24. And these are all basically the same, just different numbers. And if you saw that one example and it makes sense, then these should be fine. Okay, number 30. Here we have some more fractions. So we have b over 13 minus 3b over 13 equals 8 over 13. So here all the denominators match. So what we want to do when we have multiple fractions, we always multiply by the lowest common denominator. But since they're all 13ths, you're just going to multiply by 13. And that's actually is going to make it really easy, because when we multiply each of these terms by 13, it actually cancels that denominator. Okay, so when I multiply this by 13, it really just cancels with the denominator. So that's going to leave us with b, just b. Here, minus, again, same deal. That's 3b, and then equals, and then we'll just have 8 over here. So b minus 3b, that's negative 2b, equals 8. Then divide both sides by negative 2 to get b by itself. And remember, when I divide by a negative, positive divide by negative is negative. So it's going to be negative 4 over here. So b is negative 4. B is the value of negative 4. Okay, next one. 5y minus 3/5 equals 4/5. So what would be my first step here? Hopefully you see, well, I'd multiply by 5 on every term here, and that'll get rid of my fractions. So 5 times 5y, that's 25y. Minus, here the denominator cancels with what we're multiplying by, so that's going to give you minus 3 equals, and then on this one, 4. Now to get y by itself, we're going to add 3 both sides of the equation. So that'll be 25y equals 7. Then divide by 25 on both sides of the equation to get y by itself. So here this fraction does not reduce, so it'll just be 7/25. Okay, it's okay if your answer comes out to a fraction. No big deal. Okay, 32. This one's a little bit different because they have two different denominators here. So we have n over 5 minus 3n/10 equals 1/5. So here we want to multiply by the lowest common denominator. Now, when we're doing fifths and tenths, our lowest common denominator is actually 10, right? Because 10 is divisible by 5, but 10 is also divisible by 10. So that's kind of the key. You're looking for a number that's divisible by all of the denominators. In this case, you have fifths and tenths. So 10 is divisible by 5 and divisible by 10. So when we multiply this through, what's going to happen is you're going to divide by the denominator and then multiply by the numerator. So 10 divides by 5, that's 2, right? 10 divided by 5 is 2, then times n, so that's going to be 2n. Here, when you do where you're multiplying by matches, it just cancels, right? So that's just going to leave you with 3n. Equals, and then on the other side, 10 divided by 5 is 2. 2 times 1 is 2. Now on the left side, we can combine these 2n and minus 3n. We could combine those. That's going to be negative 1n equals, and then 2 on the right. Divide both sides by negative 1 to get n by itself. N equals 2 divided by negative 1 is negative 2. Okay, 33. Okay, here's another one with a bunch of different denominators. So we have 2/3 plus 3m/5 equals 31/15. Here, our lowest common denominator. What do you suppose our lowest common denominator is here? Well, in this case, it's going to be 15. because 15 is divisible by 3. It's also divisible by 5, and it's divisible by 15. So when you multiply this through, it should cancel out all your fractions for you. So 15 divided by 3, that's 5. And then you multiply by the numerator. So 15 divided by 3 is 5, times 2 is 10. Plus 15 divided by 5 is 3, times 3m is 9m. Equals, and then over here, that's just going to leave you a 31, right? Because 15 and 15 cancel. All right, we're going to subtract 10 both sides of the equation. That'll leave us with 9m on the left equals 21 on the right. Divide by 9 both sides of the equation to get m by itself. So here we have 21/9. Now this one reduces by 3, so that would be 7/3. Once we divide both top and bottom by 3, it reduces down to 7/3. So you always want to reduce the fractions if you can. In this case, we can reduce this because both of these are divisible by 3. Okay, 34. Here we have n over 2 minus 2n/16 equals 3/8. Now again, we're looking for our lowest common denominator. So we're looking for a number that's divisible by 2, divisible by 16, and divisible by 8. In this case, 16 is our lowest common denominator. So we're going to multiply each of these by 16. Now when we multiply this first one, 16 divided by 2 is 8. 8 times n is 8n. Minus, when you multiply this one, that just cancels out the denominator. We're left with minus 2n. Equals, and then over here, 16 divided by 8 is 2. 2 times 3 is 6. So we can combine this 8n with minus 2n, and that's going to leave us with 6n equals, and then 6 over here. Divide both sides by blah, blah, blah. Divide both sides by 6 to get n by itself. N equals 1. And again, you can always plug it back in to make sure it works. Okay, 35. Here we have b thirds plus 1/8 equals 19. So what would be the lowest common denominator for the thirds and eighths? What would be a number that's divisible by 3 and also divisible by 8? So the answer here would be 24. We're going to multiply by 24 because it's divisible by 3 and also divisible by 8. So when we multiply this through, we should not have any fractions when we multiply it through. So 24 divided by 3 is 8. 8 times b is 8b. 24 divided by 8 is 3. 3 times 1 is 3. And then we also do 24 times 19. Which is 456. To help us get b by itself, we're going to subtract 3 on both sides of the equation, giving us 8b on the left equals then 453. Divide by 8 on both sides of the equation to get b by itself. Okay, now this fraction does not reduce, so we're going to leave it just as is. 36. 1/4 plus 4x fifths equals 11/20. Now in this case, what's going to be my lowest common denominator? Well, in this case, it's going to be 20 because 20 is divisible by 4, 20 is divisible by 5, and of course 20 is also divisible by 20. So we're going to multiply this through, distributing the 20. So 20 divided by 4 is 5. 5 times 1 is 5. 20 divided by 5 is 4. 4 times 4x is 16x. And then 20 cancels with the 20 here. So that's 11. To help us get x by itself, we're going to start by subtracting 5 on both sides of the equation, canceling it out here. 16x equals, and then 6 over here. Dividing by 16 on both sides of the equation will give us x by itself. X equals, now in this case, I could reduce by 2. I could divide both top and bottom by 2 to simplify my fraction. So that'll give us 3/8. Okay. Remember, if you can simplify the fraction, you always should. And in this case, you can simplify 6/16 to 3/8. Okay, 39. 39, this one's a little bit easier. So 1.06 g minus 3 equals 0.71. So the thing here is decimals, you just treat them, they're just normal numbers, okay? So don't worry about if it's a decimal or not. It's no big deal. You can still add them to both sides. You can still divide them on both sides. You can still subtract them on both sides. So your goal is the same. You're just trying to get your variable, in this case, we're trying to get g by itself. So we want to get g by itself here. And so the first step here, we're going to add 3 to both sides of the equation. That'll cancel over here, leaving us with 3.71 on the right, and then 1.06 g on the left. Now, same as before, if I want to get rid of this 1.06, I'm going to divide by that. So divide by 1.06, both sides of the equation. Okay, so really it's no different than what we've done. And of course, you could always use the calculator. I am not anti-calculator. Feel free to use the calculator whenever you need to. In this case, g is 3.5. So it didn't really complicate things too much. Number 40. I'm going to let you go ahead and try that one on your own. Again, it's just with decimals. If you need to, you can follow the example above. Okay, 59, we get into a word problem. So if you're ready for it, go ahead and look at that. I'm going to read it out loud, and please follow along in your textbook. It says bowling. 3 friends go bowling. The cost per person per game is $5.30. The cost to rent the shoes is $2.50 per person. The total cost is $55.20. How many games did they play? So 3 friends go bowling, and the cost per person per game is $5.30. So for one game, for the 3 friends, we would do 3 times $5.30. And that tells us that just to play one game, it's going to cost the 3 friends $15.90. We'll just call it 15.9. This is for each game. So we're going to multiply that by x, where x is the number of games. So $15.90 times however many games they decide to play. Plus they have to rent shoes. So the 3 friends have to rent shoes. It's $2.50 per person. So since there's 3 of them, that's going to be $7.50 in total. Now the total amount that they spend is $55.20. Okay. So now we want to solve for x, and that'll tell us how many games they played. So you'd start by subtracting $7.50 to both sides of the equation. Okay, 55.2 minus 7.5 is 47.7. And on the left side, we still have 15.9x. Go ahead and divide both sides by 15.9 in order to get x by itself. So here you'd get x equals 3. So they played a total of 3 games. So since it's a word problem, I want you to write in a complete sentence that the 3 friends played a total of 3 games of bowling. Number 60, another word problem. Moving expenses. A college student is moving into a campus dormitory. The student rents a moving truck for $19.95 plus 99 cents per mile. Before returning the truck, the student fills the tank of gasoline, which costs $65.32. The total cost is $144.67. How many miles did the student drive the truck? Okay, so he spent $19.95. This is to rent it, plus it was 99 cents per mile. So we're going to do 99 cents times the number of miles. So 99.99x. Plus he filled up the gas tank, which cost another $65.32. And that gives him a total cost of $144.67. Okay. So now we want to solve for x. Hopefully you can see that on the left side of the equation, we can combine these two like terms, 19.95. We could add that to the 65.32. Since they both don't have x, they're just constant numbers, we can combine those. So 19.95 plus 65.32. Just adding those together, that gives us 85.27. Plus we have the 0.99x equals, and then on the other side we have 144.67. Now we're going to get rid of this 85.27 by subtracting it on both sides of the equation. This gives us 59.4. On this left side, we still have 99.99x. Go ahead and divide both sides by 99 cents. And this will tell us how many miles he drove. 60. So he drove a total of 60 miles. Since this is a word problem, make sure to write your answer in a complete sentence. Okay, once you're done with that, we're going to move on to the next section. Starting on page 105, we're going to look at number 10. So these ones aren't too bad, at least to start. We have 5x minus 1 equals x plus 15. Now notice there's x's on both sides of the equation. Now generally speaking, we don't like to have our variable on both sides. We would prefer if all of the x's were together on the same side. So in order to make that happen, we're going to go ahead and subtract x over here, and then we're going to have to subtract x on the other side as well. A lot of people make the mistake and they'll say, oh, 5x minus x is just 5. And that's not accurate. The correct way would be 5x minus x is 4x. Okay. And then on the right side, we still have 15. To get x by itself, we're going to add 1 both sides of the equation. That'll give us 4x on the left equals 16. To get x by itself, we're going to divide by 4. Because remember, 4x means 4 times x. So in order to cancel out multiplication, you divide. So we're dividing by 4 on both sides to cancel that out. That'll leave you with x by itself and 4 over here. Now just a reminder, you could always check your answer by plugging it back in, right? 5 times 4 is 20. 20 minus 1 is 19. This side will also give you 19. X plus 15, where x is 4. 4 plus 15 is also 19. Okay. With that in mind, see if you can do number 11 on your own. Number 12 on your own. Number 13 on your own. 14. We'll go ahead and work on number 14 together. So here we've got 8 minus 2y equals, and then we have 3y minus 2. So notice again, we have y's on both sides. We don't like that. Let's get all our y's together on the same side. So we're going to subtract 3y both sides. Once these cancel, you still have negative 2 on the right. And then over here, this would be 8 minus 5y now. Okay. Subtract 8 both sides of the equation. This will cancel this. Negative 5y equals negative 10. Dividing by negative 5 both sides of the equation to get y by itself. So that'll leave us with y equals, here negative divided by negative is positive, so that's positive 2. (15), try this one on your own. All right, and now number 20. So number 20, that's on the next page. It's another word problem. So it says business. A hairdresser is deciding where to open her own studio. If the hairdresser chooses location A, she will pay $1,200 per month in rent and will charge $45 per haircut. If she chooses location B, she will pay $1,800 per month in rent and will charge $60 per haircut. How many haircuts would she have to give in 1 month to make the same profit in either location? So I'm going to help you set up this problem. So in the first option, option A, she would have to spend $1,200 per month on rent, but she would get well, let's call this negative, right? Because she had to spend that. But she would get $45 times however many haircuts. Now, if she chooses the location B, she would have to spend $1,800 per month. So spending, I'm calling it negative. But she would gain $60 times however many haircuts. Okay, so let's go ahead and solve this. We're trying to get x by itself. But notice we have x on both sides, so we would have to subtract 60x here. I'm going to subtract 60x here. Remember, whatever we do to one side of the equal sign, we always do to the other side of the equal sign. So that'll give us negative 15x over here. And we also have the negative 1,200 over here as well. So we have negative 1,200 minus 15x. On the right side, we have negative 1,800x. Or just negative 1,800, sorry, no x. We're going to add 1,200 both sides of the equation. Let's cancel that. That'll give us negative 600 on the right and negative 15x on the left. To help us get x by itself, we're going to divide by negative 15 and divide by negative 15. So that'll give us x equals, I believe that's 40. Yeah, 40. So if she gave 40 haircuts, then she would have the same amount of money no matter which place she picked. Okay, so that's what I want you to state in a complete sentence. If she gave 40 haircuts, then she would make the same amount of money regardless of location. Okay, 21. So this one's got some distribution going on. So we have 3 times q minus 5. So this 3 is going to be distributed here. Equals, and then on the right side, we have 2 times q plus 5. So in this case, the 2 will be distributed over here. So the 3 gets distributed here. So that's going to be 3q minus 15. On the right side, we're going to have 2 getting distributed here, 2q plus 10. Now notice we have q's on both sides of the equation, so hopefully you remember we don't like that. So we're going to subtract 2q here and subtract 2q here. 3q minus 2q is 1q. We have a minus 15. equals, and then on the right side we have 10. Lastly, to get q by itself, we add 15 to both sides of the equation. That'll be q equals 25. (22). Here we have 8 minus, and then in parentheses, 3 plus b equals, and on the other side we have b minus 9. So here, this one's a little bit tricky, but we're not going to distribute the 8. What actually gets distributed is just the negative, okay? It's a little bit tricky, but the negative is going to change the signs of the stuff in here. So it's going to become 8 minus 3 minus b equals, and then over here we have b minus 9. On the left side, we can combine the 8 minus 3, that's 5. So we have 5 minus b equals, and then over here we have b minus 9. We can subtract b on both sides of the equation, giving us 5 minus 2b equals, and then on this side, negative 9. We're going to go ahead and subtract 5 on both sides of the equation to help us get b alone. That'll give us negative 2b equals negative 14. Lastly, to get b by itself, we divide both sides by negative 2, giving us that b is 7. Again, a negative divided by a negative is positive. Question 44. So now we've got some word problems here, 44, 45, and 47. 44, skiing. A skier is trying to decide whether or not to buy a season ski pass. A daily pass costs $67. The season ski pass costs $350. The skier would have to rent skis with their pass for $25 per day. How many days would the skier have to go skiing in order to make the season pass less expensive than the daily pass? So the $25 rental per day, I don't think that makes a difference because he would have to rent the skis whether he got the daily passes or the season pass. So that shouldn't matter. But if he goes with just daily passes, he's paying $67 per day. So $67 times however many days. And we want to know, when does that equal to the season pass, which is $350. To get x by itself, we're going to divide by 67 both sides. So that'll give us that x equals 5.22, we'll say. So what you want to say is that if he goes skiing more than 5 times, so if he goes skiing 6 times or more, then he should go with the season pass. But if he's skiing 5 times or fewer, he should go with the daily passes. Okay. 45. One health club charges $50 sign-up fee and $65 per month. Another club charges $90 sign-up fee and $45 per month. For what number of months is the cost of the clubs the same? So for the first club, it's $50 for the sign-up plus $65 a month. For the second club, it's a $90 sign-up plus $45 per month. So $45 times the number of months. Okay, now we want to solve for x. I want you to go ahead and try to finish that one on your own. Okay? Solve for x and then answer in a complete sentence. 47, business. A small juice company spends $1,200 per day on business expenses plus $1.10 per bottle of juice that they make. They charge $2.50 for each bottle of juice they produce How many bottles of juice must the company sell in one day in order to equal its daily costs? So the costs are going to be $1,200 plus $1.10 times each bottle of juice. And they receive, or in other words, their revenue is $2.50 per bottle of juice. Okay. So here, what would be our first step? Hopefully you can see I could subtract 1.10x on both sides here, giving us 1,200 on the left equals $1.40 on the right. Divide by $1.40. That'll give us that x equals $857.14. So we could just say that they would have to sell more than 857 bottles of juice in order to start making a profit. Okay, on to the next section that starts on page 168. So I'm going to go ahead and turn the textbook to there. Okay, number 8. It says, write an inequality that represents each verbal expression. So it says V is greater than or equal to 5. So I just write V is greater than or equal to 5. So if you remember, this way is greater than, and this way is less than. So this is greater than, and this is less than. Okay. For number 9, go ahead and try it on your own. Now 10 is where it gets a little bit weird. It says 3 less than G is less than or equal to 17. So G less 3 less than G. So how do we write that? So we only use these ones if it says is less than or is greater than. Okay, so it's a little bit tricky. So this one says 3 less than G. So we'd write G minus 3 there. So this is 3 less than G. Is less than, so is less than or equal to 17. That's a tricky one. Number 11, the quotient of K and 9, so the quotient means we're dividing, so K and 9, is greater than 1/3, is greater than 1/3. Number 12. So here it says determine whether each number is a solution to the given inequality. So the way I would do this is you could plug in each value and see if they work. But what I would do is just solve the inequality. I think well, you're going to learn more if we solve the inequality. So we're going to go ahead and do that. So we have 3y minus 8 is greater than 22. And to solve this inequality, you basically do the same as with equations. You're just going to go ahead and get y by itself. The one key difference, and I'll remind you if we have a problem like this, is that if you multiply or divide both sides by a negative, then that'll flip your inequality. That's the main weird difference. In this problem, we won't have to worry about that, but in other problems, we might. So we're going to add 8 both sides of the equation. That'll cancel that. Oh, did I say equation? I should have said inequality, but you know what I mean. Divide by 3 both sides. So since we're dividing by a positive, we don't need to flip the inequality. Only if you divide by a negative, then you flip. Okay. So our answers should be any value that's any value that's greater than 10. So when I look at my A, B, and C, my A is 2, so that's not going to work. My B is 0, that's not going to work. And my C is 5, that's not going to work. None of those values would work. Okay. For number 13, we have 8m minus 6 is less than or equal to 10. So my first step for this inequality will be to add 6 both sides of the inequality. Here we'll have 8m is less than or equal to 16. Dividing both sides by 8 to get m by itself gives us that m is less than or equal to 2. So we are only accepting values that are less than or equal to 2. So the a here is 2. So a works, right? Because a, which is 2 in this case, is less than or equal to 2. B is 3. That doesn't work. And then C is -1. So C also works. So we're going to A and C both are less than or equal to 2. Okay. Try number 14 on your own. For number 15, this one's a little weird. Oh, we don't have to do 15. Okay. 17. 17 says x is less than -1. And there, we want to match the graph. So why don't we just graph this? So here, let's say is 0. -1 would be over here. And since it has it does not have the equal to, then it's going to be an open circle. And we're looking for values that are less than -1. So those values are over here. So this is the graph we're looking for. Now, when we look at our answer choices, that's answer choice D in this case. Okay. For 18, its x is greater than or equal to -1. So again, I would draw my number line. I'll put 0, and I'll put my value I'm looking at, in this case, -1. And in this case, it's greater than or equal to. So that's going to be a solid dot because it has the or equal to. And it's greater than or equal to that. So that's going to go over here. So that's going to be answer choice B. Okay. Try 19 and 20 on your own. 21, we're just graphing it. So same as those others. Try 21, 22, 23, and let's go on to 29. So here they give you the graph, and you need to find the inequality. So on this graph, they're showing, so they have 0 over here, and they're showing -4 here, and they have an open circle, and they're going to the right. Okay, so that would be, in this case, x is greater than, not or equal to, just greater than, since it's an open circle, -4. Okay, hopefully that makes sense. Let's try the next one, number 30. Here we have a number line once again. And they show 0 over here, 8 is over here. Now, you can put all the numbers if you want to, but I don't like to, so I'm not going to. But it has a closed circle, and it's going this way. So these values are less than 8. So I'm looking for x values that are less than or equal to 8. Notice I put the or equal to because it has a filled in circle. So when it's filled in, it means it needs that equal to. Right? If it's open circle, then you don't put that. Okay. Try 31 and 32 and 33 and 34. Try these on your own. Number 35. The restaurant can seat at most 172 people. So the number that the restaurant can seat is less than or equal to 172. Because 172 is the maximum, it's the most. So it's less than or equal to that. Okay. 36, a person must do at least 35 years, must be at least 35 years old to be elected president of the United States. So the age of someone needs to be greater than or equal to 35. So you cannot run for president, unfortunately, at least not for a few years. Okay. A light bulb can be more than 75 watts to be safely used in this light fixture. So a light bulb, no more than. So it needs to be less than or equal to 75 watts. Okay. Hopefully those made sense. Maybe watch those again and see if those make sense. Okay, 42. Here's a word problem. So please follow along as I read aloud. Suppose your school plans a musical. The director's goal is ticket sales of at least 4,500. Adult tickets cost $7.50 and student tickets cost $5. Let A represent the number of adult tickets and S represent the number of student tickets, which inequality represents the director's goal. So they charge $77.50 times the number of adult tickets. So times A is the number of adult tickets. Plus, they also bring in money from student tickets. In this case, $5 for each student ticket, S for student ticket. And so this is the money they're bringing in. And so they want to bring in at least 4,500. So the amount of money they're bringing in needs to be greater than or equal to 4,500. So this is the inequality they're looking for. So that would be D in this case. You can see the answer choices there. D is the correct. All right, let's move on to the next section. It's on page 58 of your workbook. We're going to go to page 174 of the textbook. Okay. Starting with number 13, what we need to do is solve the inequality and then graph it. So we're going to do y minus 2 is greater than 11. So in order to solve this, the first thing we would do is add 2 to both sides of the inequality. That'll give us y is greater than 13. Then they want us to graph it. So on the number line, we just put 0 here. 13 is somewhere over here. This will be an open circle, and we're looking for values that are greater than that. And that's it. Okay. See if you can do number 14 on your own. Number 15, here it's a little bit different. So we have -6 is greater than c minus 2. Now again, I'm trying to get c by itself. So what I'm going to do is add 2 to both sides. This will give us -4 is greater than c, because this cancels. So -4 is greater than c. So how that's going to look on the number line? Well, I'm going to put my 0, going to put my -4. I know it's going to be an open circle, but notice I've got -4 is greater than c. In other words, c is the values that are going to work for c need to be less than -4. So it's going to be over here, right? And you could always try a test number, right? Like if I picked a number over here, like 7, if I put 7 here, that would not work, right? Because -4 is not greater than 7. But if I picked a number over here, like -7, it would work, right? -4 is greater than -7. So you know that you went the correct way. Okay. Try number 16 on your own. Try number 17 on your own. And number 69 is going to be on page 176. Okay, 176. This one's another word problem, so please follow along as I read aloud. It says, to enter a competition, students must score a total of at least 450 points on 5 qualifying tests. Each test is worth 100 points. On the first 4 tests, your scores were 94, 88, 79, and 95. What are 3 possible scores you can earn on the last test in order to enter the competition? So your scores so far are 94, 88, 79, 95. And then you're going to take one more qualifying test, which we don't know that score yet. So we're just going to put X for that. But we know you need to have at least 450. So 450 is, we need to have a total score of greater than or equal to 450. Now, hopefully you can see that on the left, we can combine like terms. We can combine all these constants together, right? 94 plus 88 plus 79 plus 95. So here we have 356 plus X is greater than or equal to 450. Subtracting 356 from both sides of the equation to help us get X by itself gives us that X has to be greater than or equal to 94. So for your last test, you need to score at least 94, basically. So you could score at 94, would be acceptable, 95, 96, 97, 98, 99, or you could score 100. So these are your possible scores where you can be able to enter the competition. So I want you to write in a complete sentence that these are the acceptable scores in order to enter the competition. Okay, once you're done with that, let's go and move on to the next section, starting on page 190. 190 of your textbook. And we're going to be starting with problem number 17 here. So here we're just getting more and more complicated with these inequalities, but hopefully they're not too bad. Let's take a look at number 17. 3 times k minus 5 plus 9k is greater than or equal to -3. So hopefully you can see that the first step here would be to distribute this 3 here. So that'll give us 3k minus 15 plus 9k is greater than or equal to -3. We can combine the 3k plus 9k since they're on the same side over here. So that's going to be 12k minus 15 is greater than or equal to -3. We're going to add 15 to both sides of this inequality. That'll give us that 12k is greater than or equal to 12. Dividing by 12 on both sides to get k by itself gives us that k is greater than or equal to 1. And that's it. Okay? It's basically very similar to when we solve equations. Whatever you do to one side, you do to the other. Okay? But the main thing that's different is if you divide both sides by a negative. If you divide both sides by a negative or multiply both sides by a negative, that's going to flip your inequality. Okay? In this problem, we didn't have to worry about that, but you're going to see that in other problems. Let's take a look at the next one, number 18. So here we have a negative in front of this parentheses, 7c minus 18, and then minus 2c, and this needs to be greater than 0. So let's go ahead and distribute this negative here. So that's going to be negative 7c plus 18 minus 2c is greater than 0. Again, I just distributed this negative. that's going to change the signs here. That's why this is now a negative 7c and a positive 18. Okay. Now on this left side, I can combine the negative 7c and this negative 2c to make negative 9c. We have a plus 18 is greater than 0. Subtract 18 to both sides of the inequality to help us get c by itself. Then we have negative 9c is greater than negative 18. Lastly, to get c alone, we're going to divide by negative 9. Divide by negative 9. So here we divided both sides by a negative, right? So that's going to give us that c is less than 2. Okay, because remember, if you divide both sides by a negative, that flips your inequality. Okay, so it changes from a greater than to a less than in this case. Try number 19 on your own. Number 20 here, let's go and work on this. So we got negative 4 is less than or equal to 4 times 6y minus 12 minus 2y. Let's go ahead and distribute this 4 into this parentheses. So that'll give us negative 4 is less than or equal to 24y minus 48. And then this minus 2y is also here. Then we have minus 4 is less than or equal to. We can combine this 24y with this minus 2y. That's going to be 22y minus 48. We could add the 48 to both sides of the inequality. This gives us 44 is less than or equal to 22y. Then to get y by itself, we divide both sides by 22. This will give us 2 over here is less than or equal to y. Here we do not flip the inequality because we divided both sides by a positive. So no need to flip. Try 21 on your own. Let's go and work on number, 44. Okay, so here we have quite a few word problems now. Number 44. Think about a plan. Your cell phone plan costs $39.99 per month, plus 15 cents for each text message you send or receive. You have at most $45 to spend on your cell phone bill. What is the maximum number of text messages that you can send or receive next month? So our cell phone bill costs $39.99. Plus, we also are charged 15 cents times the number of text messages. So 15 times X, where X is the number of text messages. But we have at most $45 to spend. So this is the amount we're spending. The amount we're spending needs to be less than or equal to $45. So what would we do first to help us solve for X? We're going to go and subtract $39.99, both sides of the inequality. That'll leave us with 0.15x on the left is less than or equal to. And then here, this would give us $5.01. Divide both sides by 0.15. That'll give us that X is less than or equal to. So the number of text messages you can send is less than or equal to 33.4. So really 33. So what I would say is you, as a complete sentence, you'll be able to send at most 33 text messages, right? Because you can't send or receive 0.4 of a text message. Okay. Number 45. Again, all these word problems, make sure you're answering them in a complete sentence. Number 45. The student council wants to rent a ballroom for the junior prom. The ballroom's rental rate is $1,500 for 3 hours and $125 for each additional half hour. Suppose the student council raises $2,125. What is the maximum number of hours for which they can rent the ballroom? So to rent the ballroom, it's $1,500, and that gets them 3 hours automatically, right? Says that's $1,500 for the first 3 hours. Plus, it's $125 for each additional half hour. So we're going to just call it $250 for each hour. So $250 times however many hours here. And the most they can spend is what they raised, which was $2,125. So the amount they spend needs to be less than or equal to whatever amount they raised, which was $2,125. What I would start with is subtracting 1,500 on both sides of the inequality. Here, then we'd have 250, x is less than or equal to, and then here would be 625. Divide both sides by 250. X is less than or equal to 2.5. Okay, so remember they originally got 3 hours already, and so they can have at most another 2.5. So we would say that 5.5 is the total amount of time. So 5.5 hours is the total amount of time that they can rent the ballroom. Okay, number 51. A sales associate in a shoe store earns $325 per week plus a commission equal to 4% of her sales. This week, her goal is to earn at least $475. So the amount of money she's going to raise is going to be, we want it to be greater than or equal to $475. So she wants to earn at least $475, meaning she wants to earn a greater than or equal amount to $475. Okay. At least how many dollars worth of shoes must she sell in order to reach her goal? So she earns $325 even if she sells nothing. But she also earns 4% commission, meaning however much money she sells, she gets 4% of that. So plus she gets 4%, so 0.04, we'll say, times however much she brings in, however much she sells. All right, now let's go ahead and solve the inequality. We're going to subtract 325 from both sides of the inequality. So that gives you 0.04x is greater than or equal to, this is 150. Dividing both sides by 0.04 will give us x by itself. So that'll give us that x is greater than or equal to, meaning the amount she needs to sell is greater than or equal to 3,750. So she needs to sell $3,750 worth of stuff. I guess shoes. $57. This one's on page 192. Freight handling. The elevator of a building can safely carry no more than 4,000 pounds. So I know the amount it can carry is less than or equal to 4,000. Right? So the elevator can hold less than or equal to 4,000. A worker moves supplies in 50-pound boxes from the loading dock to the fourth floor of the building. The worker weighs 210 pounds, and the cart he uses weighs 95 pounds. So he has to bring himself on the elevator and the cart. So the amount of weight just from himself and the cart that needs to come onto the elevator is 305 pounds. So that's his weight plus the cart's weight. Plus, he's bringing on boxes. Each of the boxes weigh 50 pounds. So plus, he's bringing on 50 pounds times however many boxes. Now, we want to figure out how many boxes he can load onto the elevator safely. So what we would do is subtract the 305, both sides of the inequality. This will give us 50x is less than or equal to 3,695. Divide both sides by 50 to get x by itself. Will tell us that the number of boxes he can bring on is less than or equal to 73.9. So we would say he can bring onto the elevator at most 73 boxes. So make sure you answer that in a complete sentence. 57B. The worker needs to deliver 275 boxes. How many trips must he make? So each trip he can bring at most 73. So each trip he can bring 73 each trip. So how many trips is it going to take for him to bring up 275 boxes? Divide by 73 on both sides of the equation. This will tell you how many trips he would need to make. Here we get 3.77, but you can't have 0.77 of a trip, so you just have to make another trip. So we would say he would need at least 4 trips in order to bring up the boxes. So he would need to make 4 trips to bring up all the boxes. Okay, when you're done with that, let's go ahead and move on to the next section, starting on page 204. And we're starting on page 11 here. Okay, we haven't seen ones like this, so I'm going to go over it pretty slowly, but they're actually not too hard. Here, if you see this problem, it's -4 is less than, and then we have k plus 3 is less than 8. So this is what we call an AND statement. So -4 is less than k plus 3, and k plus 3 is less than 8. Okay, so in other words, k plus 3 is between these two values. K plus 3 is between -4 and 8. So when we solve for k, we're going to need to subtract 3 to solve for k, right? But then you subtract 3 on every side of this inequality. Okay, so that's going to give us -7 is less than k, which is less than 5. So k would have to be between -7 and 5. Okay, hopefully you can see how I got that. Remember, I subtracted 3 to get k by itself. You'd have to subtract 3 over here on this side, on this inequality, and also on beyond this inequality as well. Okay, then we get this compound inequality like this. Now, how do I graph that? Because it also says graph your solutions. So what we would do is we're going to do a number line here. And I'm just going to put 0. Just going to put 0 right here. Here's where 5 would be, right? And here's where -7 would be. Okay. You don't have to put all the numbers there unless you really want to. These would both be open circles, right? Because they both have strictly less than. And we would go in between here. All right, which should make sense, right? Think about what numbers would work here, right? For example, 0 would work here, right? -7 is less than 0, and 0 is less than 5. Or 1 would work here as well. -7 is less than 1, and 1 is less than 5. So you can see here that in these AND statements is what we call them. It would be in the middle here. Okay, and you can always try numbers to make sure. Okay, number 12. Here we would have 5 is less than or equal to y plus 2 is less than or equal to 11. Okay, so here we would subtract 2 and then subtract 2 here and subtract 2 here. So that'll give us 3 is less than or equal to y, and y is less than or equal to 9. So where would this be? What would this look like on our number line? So I'm going to put 0 over here, and 3 would be like here, 9 would be over here. Here we would both use closed circles because in this case, these have the or equal to. So these are going to be closed circles. Okay. And these values are between 3 and 9. 13. 3 is less than 4p minus 5, which is less than 15. So here we would add 5 to all three sides. Adding 5. So this would be 8 is less than 4p. 4p, which is less than 20. Then to get p by itself, we divide by 4, divide by 4, divide by 4. Gives you 2 is less than p, which is less than 5. Okay. I'm going to trust you're going to go ahead and graph that for me. Go ahead and try graphing that on your own. Number 14, this one looks crazy, but let's go ahead and try it. So it's 15 is less than or equal to, and then we have a fraction here. So we have 3 in the denominator, and we have 20 plus 11 plus k in the numerator, and then less than or equal to. Then on the right side, we have 19. So what I would do is multiply everything by the denominator. In this case, we're going to multiply everything by 3. So we're going to multiply the 15 times 3. Then we're going to multiply this fraction times 3. And then we're going to multiply this over here times 3. And that'll cancel our denominator when we do that. So 3 times 15, that's 45, is less than or equal to. And then here we have 20 plus 11 plus k. And then is less than or equal to 3 times 19 is 57. Then we can, in the middle here, we can combine the 20 plus 11. So that's going to be 45 is less than or equal to 31 plus k, which is less than or equal to 57. To get k by itself, we're going to subtract 31 on all three sides here. So that'll give you 14 is less than or equal to k, which is less than or equal to 26. Okay, and then go ahead and graph that on your own. Number 15, here we have 1/4 is less than. Then we have 2x minus 7 over 2, and then is less than 5. So what are we going to multiply everything by here? Well, here I've got multiple fractions, so we're going to multiply by the lowest common denominator. In this case, that's going to be 4. So we're going to multiply everything by 4 here. When we multiply this by 4, that cancels with the denominator. So that's just going to give you 1. When we multiply this by 4, the 4 cancels with the 2, right? So 4 divided by 2 is 2. And then so we'd still multiply the top by 2. So it'll be 2 times 2x minus 7. The 4 also multiplies with the 5 over here. So that's less than 20. Okay. The reason there's this 2 here is because 4 divided by 2 is 2. And so you'd still have to multiply that when you divide it. The 4 divided by 2, that gives you 2. So that 2 needs to multiply with the top here. So what we're going to do now is distribute this 2 to both of these. So that'll be 1 is less than 4x minus 14, which is less than 20. Adding 14 to each side here. Make sure you're showing all your work. So this is 15 is less than 4x, which is less than 34. Dividing by 4 on all 3 of these. This will give us just x here. Now, as far as these, maybe you should write these as decimals. It'll make it easier to find where they are on the graph. So let's go ahead and do 15 divided by 4. And so as a decimal, it's 3.75. And then here, 34 divided by 4 would be 8.5. So just draw those on the number line, and it'll be the numbers in between. 17. Okay, so these are a little bit different. These are what we call OR statements. Okay, notice when you look at number 17 there, it says 6b minus 1 is less than negative 7. Or, and then we have 2b plus 1 is greater than 5. So let's go ahead and solve each of these separately. So we're going to add 1 here. So that'll give us 6b is less than, and then negative 7 plus 1 is negative 6. Dividing by 6 gives us that b is less than negative 1. Let's go ahead and do the second inequality here. So we're going to subtract 1. Subtract 1. This will give us 2b is greater than 4. Dividing by 2 on both sides gives us that b is greater than 2. So this is where the OR is, right? So b is less than negative 1, or b is greater than 2. What does that look like on the number line? So let's put the 0 here, let's say. 2 is over here, and negative 1 is over here. So I want b values that are less than negative 1. So that's going to be, here's negative 1. The values that are less than that are over here. So these are the values that are less than negative 1. Here I want b values that are greater than 2. So it's going to go over this way. So generally with OR statements, they're going to go opposite from each other, right? These are different than the ones we did before where they went towards each other, okay? So OR statements generally go like this, and statements usually go towards each other. Okay, with that in mind, go ahead and try number 18 on your own. Let's go ahead and do 19 together. So here we have 4d plus 5 is greater than or equal to 13, or 7d minus 2 is less than 12. Okay, so subtracting 5 over here, both sides of the inequality, gives us that 4d is greater than or equal to 8, dividing by 4, both sides, gives us that D is greater than or equal to 2. Let's do this one now. Adding 2 to both sides. Now we have 7D is less than 14. Dividing by 7 gives us that D is less than 2. And again, this is an OR. So here, this one's a little bit strange when we graph it, but the only value we care about is 2. So we're going to put 2 here. This one says D is greater than or equal to 2. So we're going to do a closed circle here, and we're doing values that are greater than or equal to 2. So that's over here. What about values that are less than 2? Well, that's over here. So in this case, it covers the entire number line. This is kind of a weird one where it covers everything. Every single value will either fall into this or that. Okay. Let's go ahead and do number 20. We have 7 minus C is less than 1, or 4C is less than or equal to 12. Let's go ahead and do this right one, or this one over here first. So we're going to subtract 7 both sides. So that'll give us negative C is less than negative 6. Go ahead and divide both sides by negative 1 to cancel this negative. That'll give us that C is greater than 6. Notice it changed from a less than to a greater than because we divided both sides by a negative. Remember, if you divide both sides by a negative, that flips your inequality. So it flipped from a less than to a greater than. For this one, we're going to divide by 4 both sides, giving us that C is less than or equal to 3. So 4 here. Let's go ahead and graph this on our number line. So this 0 is over here, 3 is over here, 6 over here. So C is greater than 6, so that's open circle, and greater than 6. Or C is less than or equal to 3, less than or equal to, we do a closed circle, and we go to the left. Okay, go ahead and try number 21 on your own. Once you're done with that and ready to move on to the next section, let's go ahead and go there. So page 211. Starting on page number 11. Or starting on question 11, sorry. Okay. We're actually going to talk a little bit about what absolute value means. So the absolute value of a number, so if you put in a number here, it always comes out positive. So if I put in, for example, 3, this will come out as 3. But also if you plug in negative 3 into here, it also comes out as positive 3. So no matter what number is inside these lines, it comes out positive. So this is what we call absolute value. So the absolute value of a number, it'll always come out positive. So that's the key thing here. No matter what you put in the absolute value, it'll always come out positive. So whether it's positive or negative, it'll always come out positive. Okay. So for example, with number 11, let's go ahead and solve this one. It says the absolute value of n plus 3 equals 7. Now we want to try to figure out what value could go in here. So what we're going to do is going to subtract 3 both sides. So similar to what we've done before. Okay. Here we'll have the absolute value of n equals, and then 4 over here. So the absolute value of what would give you 4. So the way you would do this is basically this gets a plus or minus. So n could equal 4 or n could equal negative 4. Okay, so that's your answer. We'll put an or here. So the main thing is that 4 can go here, right? The absolute value of 4 is 4, but also negative 4 can go here. The absolute value of negative 4 is also 4, right? Either of these values could go in here and give us that. So that's why there's two solutions. Okay, see if you can follow. Let's go actually do another example. So we have 7 equals, and then we have the absolute value of s minus 3. So again, we want to get the absolute value alone first. So we're going to add 3 both sides. That'll give us 10 equals, and then over here we have the absolute value of s. So that means s could equal 10 or negative 10. Okay. Okay. Go ahead and try number 13 on your own. Let's go do 14 together. So 14 says 5 times the absolute value of d equals 20. So again, I want to get the absolute value alone. So we're going to divide by 5 on both sides of this equation, giving us the absolute value of d equals 4, meaning that d could equal 4, or d could equal negative 4. So 2 values here. (15). Why don't you go ahead and try number 15 on your own. Number 16 has the absolute value of y plus 3 equals 3. So here we would subtract 3 from both sides of the equation to cancel this. That'll give us the absolute value of y equals, and then this is 0. So here, this gives us just one value, 0. So the absolute value of 0 is 0. That's why I showed you this one, because 0 doesn't have a positive or negative version. It's just 0. Okay. 17, here we have the absolute value, and we've got r minus 8 in the absolute value. And we want to see, when does that equal 5? So this one's a little bit tricky, but once you see it, it's not too bad. Basically, whatever's in the absolute value, you're going to change it into 2 equations, one with a plus, one with a minus. So we're going to say r minus 8 could equal 5. Right? In here could be 5, and that'll give us 5. Or r minus 8 could equal negative 5, right? If r minus 8 is negative 5, this will also give me 5. Let's solve each of these separately. Adding 8 plus 8 here. So that'll give us r equals 13. And then over here, adding 8 gives us that r equals 3. Okay, and you can plug them in to make sure it works too. Let's put more. 13 minus 8 is 5. The absolute value of 5 is 5. 3 minus 8 is negative 5. The absolute value of negative 5 is 5. Okay. With that example in mind, go ahead and try number 18 on your own. As well as try number 19, number 20, number 21 we'll do together. So this one says negative 2 times the absolute value of 7d equals 14. Okay. So if I divide both sides by negative 2 to cancel that out, here we have the absolute value of 7d equals negative 7. So here is our first one that says no solution. Okay. And the reason this one has no solution is because you have the absolute value equaling a negative. Now, remember what I told you in the beginning, an absolute value, no matter what you put in there, it should always come out positive. So if you have the absolute value equals and then a negative, then that's going to be no solution. Okay, so when you have the absolute value and there's nothing else outside this absolute value, right, on this side of the equation, then and it equals a negative, that's going to give you no solution because you can't have an absolute value equaling a negative. Okay. So you have to watch out for that a little bit. Number 22, here we have -3 times the absolute value of 2w equals -12. So in this one's case, we divide both sides by -3, giving us that 2w and the absolute value equals negative divided by negative is positive. So we can do that. Here's where we'll split it into two equations. There's a fly here. It's very annoying. We'll have 2w equals 4, and then 2w equals -4. So there's a plus or minus version. Divide by 2 on both sides here. Gives you that w equals 2. Divide by 2 on both sides here. Gives you that w equals -2. So w equals 2 or w equals -2. (23). Here we have 3 times the absolute value of v minus 3 equals 9. So your first step here would be to divide by, you want to get rid of this 3 here, so we divide by that 3 first. Generally, you want to get the absolute value alone first. We want to get the absolute value by itself first, and then we'll work from there. So then we have the absolute value of v minus 3 equals, and then this side gives you 3. 9 divided by 3 is 3. Here's where we would split it into two equations. So v minus 3 equals 3, and then v minus 3 equals -3. So remember, you get a plus version and a minus version. To solve for v, we add 3 both sides, giving us that v equals 6. Here we would add 3 to both sides here, giving us that v equals 0. So v equals 6 or v equals 0. Okay. I want you to try number 24 on your own. It's very similar to number 23. Okay, number 25. Here we have the absolute value of 4f plus 1 minus 2 equals 5. So here we would add 2 to both sides to start. Remember, we want to get the absolute value alone first. So we get the absolute value of 4f plus 1 equals, and then 5 plus 2 is 7. Here's where we would split it. Oh, there's supposed to be a plus 1 here. That fly distracted me. Okay. Here we would split it into two equations. So we would have 4f plus 1 equals 7, and then 4f plus 1 equals -7. Solving each of these separately, we would subtract 1, then we have 4f equals 6, divide by 4, gives us that f equals, and then we could reduce this by 2, so that's going to be 3 over 2. Similarly here, if we subtract 1 both sides, gives us that 4f equals -8, divide by 4 to give us that f equals -2. So here we have our two answers here. Okay. Number 26 is very similar to number 25, so I'm going to let you try to do that on your own. 27. Here we have 4 times the absolute value of 2y minus 3, then minus 1 equals 11. So here we want to get the absolute value alone first. So we're going to add add 1 to both sides here, giving us that 4 times the absolute value of 2y minus 3 equals 11 plus 1 is 12. Then we would divide by 4 both sides to get the absolute value alone. That'll give us that 2y minus 3 equals 3. Then we would split it into 2 equations. 2y minus 3 equals 3. Then 2y minus 3 equals negative 3. And we're going to solve each of these separately. So let's go ahead and add 3 both sides for this equation, giving us that 2y equals 6. Dividing by 2 on both sides will give us y by itself. So y is 3. Same idea here. We're going to add 3 both sides of the equation, giving us that 2y equals 0. Divide by 2 on both sides to get y by itself. Y equals 0. So y equals 3 or 0. Okay. Number 32. Here's where we introduce some inequalities. So we have the absolute value of x needs to be greater than or equal to 3. So let's try to think of a value that would work here. Think of a value that would work in this inequality. So if I plugged in 4, that would work, wouldn't it? The absolute value of 4 would be 4, and 4 is greater than or equal to 3. But also negative 4 would work here too, right? The absolute value of negative 4 is 4, and 4 is greater than or equal to 3. So how do we set up to try to solve and graph? We want to graph it too, this type of inequality. So just like before, when we did the equalities, we would split it into a positive and negative version. We want to do that here as well. So we want to split it into a positive version. X is greater than or equal to 3, and then also a negative version. X is less than or equal to negative 3. So in this case, the first one where you keep the plus, you just keep the same inequality and keep that same, keep everything the same. But on the other one, when you change it to negative, you're going to flip that inequality, okay? And that'll give us our 2 inequalities that we need to graph. So let's go ahead and graph them now. So x is greater than or equal to 3. So let's put 0, here's 3, and here's negative 3. So x is greater than or equal to 3. So that's going to be a closed circle, and we want values that are greater than or equal to 3. This one says x is less than or equal to negative 3. So from negative 3, we want the values that are less than that. Notice that this produces an or statement. Remember we covered before, and statements go together, or statements go opposite. So this is an or statement. And generally when we have ones like this, where the absolute value is greater than or equal to, or greater than, you're going to produce a or statement. We're going to see ones that produce and statements in a bit. Let's take a look at number 33. So here we have the absolute value of x is less than 5. Again, we're going to split it into 2 inequalities. The first one, x is less than 5. And then the second one, x is, we flip that, is greater than, and then we change that to negative 5. So x is less than 5, and x is greater than negative 5. So let's go ahead and graph that. So I'm going to put 0 here, 5 over here, negative 5 over here. Both of them are open circles, right? Okay. X is less than 5. So when I look at 5, I want values that are less than that. And this one says X is greater than negative 5. So from negative 5, I want greater than that. Notice they go towards each other. This is an and statement. Okay? So when we have the absolute value of something is greater than, this would produce an or statement, right? Whereas if we had the absolute value of something is less than, this produces an and statement. Okay? So this one is an or. Whereas this one, you could combine these into an and. Okay. Number 34. So here we have the absolute value of x plus 3 is less than 5. So I know it's going to be an and statement like this, where they're going towards each other. But let's go ahead and split it into two inequalities. So x plus 3 is less than 5. So everything stays the same on the first one. Then in the second one, x plus 3 is greater than, flip the inequality, and change that to negative 5. We're going to solve each of these inequalities separately. So subtracting 3 from both sides here gives us that x is less than 2. Here, subtracting 3 gives us that x is greater than negative 8. Let's go ahead and graph them here. So I'm going to put 0 here, I'm going to put 2 here, and negative 8 over here. Open circle, open circle. X is less than 2, that's over here. X is greater than negative 8, that's this way. You can see it's an and statement. Well, we're almost done. A couple more pages to go. Number 35, I'm going to let you try that one on your own. This one will actually be an or statement, so the graph should show them going opposite directions. 36, try that on your own. This one will be an and statement, so they're going towards each other. Try 37. 38, let's go and work on that together. So here we have the absolute value of 2c minus 5 is less than 9. One thing you don't realize is how much talking you do in these videos really hurts your throat. So here we have 2c minus 5 is less than 9. And then the second one will be 2c minus 5 is greater than negative 9. So for this one, we're going to add 5. Add 5. Then we'll have 2c is less than 14. Dividing both sides by 2 to get c by itself gives us that c is less than 7. Similarly, we're going to add 5 here, add 5 here to cancel this 5, giving us that 2c is greater than negative 4. Dividing by 2 to get c by itself will give us that c is greater than negative 2. So let's go ahead and graph those. So I'm going to put 0 here, negative 2 over here, and 7 over here. So c is less than 7. That's going this way. C is greater than negative 2. That's going this way. This is an and. Number 39. I want you to go ahead and it's very similar to the one we just did, number 38. So I want you to try that on your own. Number 40 as well. And number 41 as well. Okay. All right. So finish those up. And I guess that's it. I hope that all made sense. I hope that you were able to get through it. If it all made sense and it was all easy for you, and you were able to do all the ones that I asked you to do on your own, then your packet is going to be looking really good. And on top of that, you'll do very well in the test. So hopefully that all made sense. Hopefully you're able to get through it. But if you have any questions, or if you want to set up an appointment with me, you could always do so by emailing me. My email is ttrigg@ofy.org. Well, with that, good luck and take care. See you next time.